we're trying to prove that 1 minus cos 2 theta is equal to tan theta sine 2 theta. So cos 2 theta can be expressed in three different ways. Cos squared theta minus sine squared theta, 1 minus 2 sine squared theta, or 2 cos squared theta minus 1. So we need to think about which one of these three things are we going to use to replace this cos 2 theta. And I think the best way to figure that out is to first manipulate the right-hand side of the identity. So, starting our proof, the right-hand side we can express as, so tan theta is sine over cos, and the sine 2 theta is 2 sine theta cos theta. So then I can simplify this. The two cos thetas cancel out. We have one on the top, one on the bottom. And this then becomes 2 sine squared theta. Okay, so the left-hand side has to equal to 2 sine squared theta. This is our left-hand side. So that suggests to me that we're going to be using this form of the identity for cos 2 theta. That will give us just sine squared theta, which is what we want. So then, switching to the left-hand side, the left-hand side is then equal to 1 minus bracket, so cos 2 theta is now 1 minus 2 sine squared theta. Expand this out, 1 minus 1 plus 2 sine squared theta, which is then 2 sine squared theta, and this is our right-hand side. So bear in mind for proof questions, you can either start with the left-hand side and show it equals the right-hand side, or vice versa, so start with the right-hand side and show it equals the left-hand side, or you can do what I've done here, where you work on both sides simultaneously, and in the end, show that we end up with the same thing. You just want to make it very clear which side you're manipulating. So I started with the right-hand side, and then worked on the left-hand side, and showed it equaled to the right-hand side. Okay, now for part B. We have hence solve in this interval here of minus pi over 2 to pi over 2. We want to solve this equation here. Okay, so whenever it says hence, that is an indication that we want to use the previous part of the question. So we want to use this identity here. So if we look at the equation that we're trying to solve, what we could do is we could replace the 1 minus cos 2x with this. As we know that 1 minus cos 2 theta is equal to tan theta sine 2 theta, so we can replace the 1 minus cos 2x with tan x sine 2x. So I'll start with that. So our equation then becomes, so keep this x squared as it is, and then that is multiplied by 1 minus cos 2x, which now becomes this, so the thetas there get replaced with x. So tan x sine 2x, and that's then equal to the right-hand side, which I'm going to keep it as is, 3 tan squared x sine 2x. Okay, now it's tempting to cancel out the sine 2x on both sides of the equation, and a factor of tan x as well. But if you did that, you would lose solutions. So in those kinds of scenarios, don't cancel out, but rather bring everything to one side and then factorize. So I'll bring the term that we have here to the left-hand side, and then our equation then becomes sec squared x minus 5 multiplied by tan x sine 2x, and then move the right-hand side to the left-hand side, so 3 tan squared x sine 2x. And now we can factorize. So we have a common factor of sine 2x and also a common factor of tan x. So we can take those two things out. So tan x sine 2x, and what we're left with is, so from this first term, so this whole thing here, we're left with sec squared x minus 5. And in the second term, we're left with 3 tan x. Okay, so we can now use this identity. Sec squared x is equal to tan squared x plus 1. And that means we can change the interior of this bracket here into tan squared x plus 1 minus 5 minus 3 tan x. Keep these two as they are for now. Simplify what we have in the bracket. So this becomes tan squared x minus 3 tan x minus 4 equals 0. And what we have here is a quadratic, so then we can factorize that. It then becomes tan x minus 4, tan x plus 1. And now we can solve this equation. So all of these four things are multiplied by one another. That means that if one of them is 0, the whole thing is 0. So our solutions become, or rather we get our solutions from, tan x equals 0, sine 2x equals 0, tan x minus 4 is 0, and finally tan x plus 1 is 0. And we're trying to solve in the interval of minus pi over 2 to pi over 2. So let's write that down here. And it's not inclusive as well. It doesn't include pi over 2 or minus pi over 2. So I'll just rewrite these two. Tan x is equal to 4 and tan x is minus 1. And we can start by solving all of the tan function equations. So these three. It'll be easier to do all of them in one go. Okay, so inverse tan of 0 gives us 0. And so for a tan function, we can add or subtract pi as many times as we need to our original value, which in this case is 0, to get all the other values in our domain. But in this case, if we were to add or subtract pi to this number, it would not end up being in our domain. So for tan x equals 0, this is the only solution that we get. For tan x equals 4, we end up with 1.326. And for tan x equals minus 1, we end up with minus pi over 4. Now because our domain is spread over an interval of pi, so if we do this value minus this value, that will give us pi, then that means that if these three values are in this domain, which they are, then if we were to add or subtract pi to any of these numbers, it would not be in this interval. So there's no other solutions for the tan x equals these three numbers. And now we can move on to sine 2x equals 0. So we have inside our sine function 2x. So for that reason, I'm going to change the domain. So multiply the domain by 2, we end up with minus pi is less than 2x, which is less than pi. So we're solving sine 2x equals 0 in this interval of minus pi to pi. Inverse sine of 0 is just 0, so 2x is 0. And if we then think of a sine graph, so our solution was over here. That's when 2x was equal to 0. And we get two other solutions, here, and those would be at minus pi and pi, but our interval does not actually include minus pi or pi. So for that reason, this would be our only solution. So we can divide both sides by 2, we get x is 0. And that corresponds to the solution that we have over here. So our final answer, or answers, would then be x equals 0, 1.326, and minus pi over 4.